Sir, is it visible?
Yes, yes, visible, sir. Visible, sir.
Shall I continue?
Just wait, sir. Say good evening to all. So today's sections, Dr. T. Vivekanandan. Now he's currently working as a professor at Sri Venkateswara College of Engineering Technology, Chittoor. He has a more than 15 years experience. He has specialized in big data, data science. He's published more than 15 papers, including SCI, Scopus journals. His more interest areas, research areas, data science, AI, and big data. I welcome Dr. T. Vivekanandan, sir, to take over these sections.
Yeah. Thank you, sir.
Thank you very much, sir. You can continue, sir.
Sir, just to confirm before I proceed, whether my slides are visible now. If I move to next slide, could you see
yes,
the
sir,
next
visible.
slide?
Yes, sir.
Okay. Okay then, sir.
So I request all the participants. Are you get it?
Participants, kindly respond. Am I audible?
Yes, sir. Audible and visible, sir.
Yeah. Thank you, sir. Thank you.
Thank you.
Yes, sir.
Yes, sir.
Okay, sir. Carry on, sir.
Yeah. Thank you, sir.
Yes, sir.
Yeah. Good evening, everyone. Myself, Dr. Vivekanandan, working as professor and head in Data Science and AML department from Sri Venkateswara College of Engineering and Technology, Chittoor. And thanks for the opportunity given for me to present here on the knowledge what I have gained in this area. So today's topic is about tools and technique which is used for big data applications. In one day FDP program, this is third day on sixth session, the opportunity was given for me. Though time is very short to cover the entire thing, I hope I could able to provide at least to some extent about the tools and techniques which are being adopted in the big data platform. Now, this is the agenda what is going to be discussed today. Let me directly get into a global snapshot as of 2022 January. If you look at this, we could able to get some insights from this particular statistics. Total population has reached about 7.91 billion, of which 5.3 billion users are using mobile phones, have their own mobile phones, of which 4.95 billion people are actually using internet, and social media users are about 4.62 billion. So this statistics provides an insight that huge amount of data is being generated and the growth of the data is exponentially increasing day by day. And it's about getting a double within a span of 18 months. And next is about the digital growth. Every year, year on year, it's about 18 million people, more than 18 million people. The total population is getting increased, of which 1.8 percentage year on year change with respect to mobile users, and 4% increase in internet users, and 10% increase in social media. This is where the major interesting point is all about. Every year, 10% of users are getting increased with respect to only social media alone. And active users, of course, is about 10% in an average, which is about 424 million people are using this. So this is a sign that huge amount of data is getting populated, and the exponential growth is being witnessed is because of this reason. This is just only the statistics to understand how the growth is taking place with respect to digital media. Now, coming to the topic, which is about what is big data and what actually makes the data as big data. So before proceeding, once again, I'm confirming, am I audible? Whether my slides are visible to you?
Yes, sir. Audible, sir. Slides are also visible.
Yeah, thank you for your response, ma'am. So this is about what is big data and what makes the data as big data. Data is generated from different sources. It may be from a small mobile device, or even it may be generated through social media, or data may be generated from other sources. And what is this big data is all about? Which is a term that refers to the data set which is highly complex, the one which is not possible to handle with the traditional resources which are available with us. We may have some set of resources, but if the data that is available with us could not be handled efficiently, then we refer that particular data as big data. The software data processing which is available with us is inadequate to handle such highly complex data, is what we term it as big data. Which means the resource what we have in terms of architecture or the algorithms or techniques or the tools, analytical tools, what we have could not able to handle such data. Now the interesting here is you have to extract some valuable insights from that. There may be huge hidden knowledge available with such a huge data. So now you need to think about what kind of architecture that we need to adopt and what kind of technique or algorithm or analytical tool that we are supposed to handle to overcome this difficulties what we have with traditional resources. In short, to conclude about what is big data, which is a massive volume of data existing, and it's not only going to have a same kind of data formats, which may have variety of data formats, and even it may be highly complex, and the one which could not be handled with whatever the traditional resources that we are going to have is what we conclude it as big data. Now, this is another interesting scenario to understand what data actually makes as a big data. Now, if you take a snapshot of 1 minute, which means 60 seconds in an internet minute, if we consider, huge data is being populated from various sources, but few are highlighted here. To take few things, from the Facebook, 1.4 million scrollings are taking place within a minute, which means within a 60 seconds, 28,000 subscribers are watching Netflix videos. 1.6 million is being spent on online purchase. If you think about this, huge amount of data is being generated, and the traditional resource what we have is not sufficient to handle such a huge volume of data. So that is the reason why we are looking for a technology or a tool, analytical tool that helps to get some insight from this huge volume of data. And if you consider from Facebook point of view alone, for every minute, for 1 minute in Facebook perspective, you see 500 new accounts are being added up, $11,700 they are generating as a income for Facebook, and 323 days of YouTube videos are being viewed on Facebook through Facebook, and other scenarios like you can see. So this is what happens in about a minute. So if you consider in a day, more than 600 terabytes of data is being generated from Facebook alone. If that is the case, the resource whatever they do have may not be sufficient to handle and may not be sufficient to take insights from the data what they have or the data generated on a single day itself. So they need some advanced tools or techniques to handle such a massive volume of data and take some valuable insights from the data whichever is available with them. And now coming to some fundamentals of big data. The characteristics of big data, if you consider in the initial, like when they started to coin about this big data, initially they started with defining a three-view model for big data characteristics. One is volume, velocity, and variety. Volume speaks about the size of data that you are going to handle. Like it ranges from terabytes to zettabytes, petabytes, and so on. The size of data that you are going to handle, whether the resource what is available with us, of course, we could not able to handle such a huge volume of data. So in that case, we need to think about this particular characteristics that supports in big data to handle such a huge volume. And another refers to velocity, the speed in which data is being generated, right? The speed in which the data is being generated. And this data may be varying from a small batch processing to streaming data, live or on, on streaming data, whichever is generated. Now, your resource should be capable of handling such, speed in which the data is being generated. And another one is concerned with variety. The data which is being available nowadays is almost unstructured, or we could say that almost 80 to 90% of data which is prevailing across the universe is completely unstructured data. So structured to unstructured, it's not that only structured data that you could handle, but now as he mentioned that about 80 to 90% of data what we have is almost unstructured form of data. Now, the resources what we have, like traditional database systems what we have, could not able to manage such a type of complex formats of data. So we need to think about the tool that could able to handle such complex type of data, mostly unstructured. So as technology has evolved, this 3V model has been replaced with 5V model, where they have added two more component in this V model. One is value and another one is veracity. Value speaks about adopting some statistical component in that, which means applying some statistical model by which you can able to take some valuable insights from the big data what is available with you. And another important component speaks about veracity. Apart from these three, value and veracity has been evolved in the next level of big data technologies. So where they were thinking about of course, we may handle huge and massive volume of data, is the data generated from the authorized source. What is the trustworthiness of the data? And authenticity and origin, reputation, all these are about, to some extent, it is about secured features, where we'll be ensuring whether it is from the reliable source and whether we could able to apply and try to get some valuable insights from that or not is also a concern while handling this big data. So this 5E model speaks about different components. And again, as technology evolved, now people are entering into 10V model. Apart from these 5V, like volume, velocity, variety, veracity, and value, the other 5V is also being considered nowadays, and mostly it is under adoption. So like validity, variability, venue, vocabulary, and vagueness. So these components are also being considered nowadays while defining the characteristics of big data. So like ensuring the data quality, ensuring the data management with respect to such a massive volume of data, and dynamic nature of the data, how it evolves, how it behaves. Dynamic behavior of the data is also taken into consideration. And of course, we may also use resources maybe from multiple platforms, which means we may not be using only a homogeneous kind of network system to handle this. Of course, we may also make use of resources residing at remote places or a cluster of resources integrated together from heterogeneous sources, so which is mostly distributed. So in that case, how you are going to manage such things, and what kind of data model you are going to make use of, how you are going to define the semantics, what kind of data structure that you are going to apply. So vocabulary speaks about this, and this particular characteristics defines about these data models and what kind of data structure and how you define the semantics and so on. Vagueness, which is completely about the tools that you are going to use, and mostly this is a confusing factor, like which tool that I need to use, what is the right tool that I am supposed to use, for what kind of data, which tool will be feasible. So this characteristics defines about that. Now this 5V model has evolved to this 10V model, and of course researchers are also thinking about, even data scientists and researchers are also thinking about how to evolve further V characteristics model from this, and that is also taking place in research. Beside this 10V model, they are also looking to add few more components into the V models of big data. Now coming to some characteristics, let us speak about few characteristics with some example. So when you consider data volume, when you take between a decade 2009 to 2020, 44 times it has been witnessed that the data size has increased, which means 44 times the data has been increased. So this shows, of course, even we can recall the more like Moore's law. Moore's law, two laws he has defined. One law states that for every 18 months, the amount of transistor embedded in an IC chip is getting double. The same law may fit to this data. Within 18 months, the total volume of data existing across the globe is getting doubled less than 18 months. Less than 18 months, this is getting double. And from zero point 0.8 zettabyte to 35, or even it is exceeding than that, which means data volume is increasing exponentially and it is getting doubled less than 18 months. If that is the case, the amount of data which grows in terms of terabytes to petabytes, exabyte, zettabyte, and so on, that is how the volume of data getting increased. And this is applicable for all the applications which is, of course, running across the globe. Either you take Facebook or you take Twitter or any social media or any other, even company point of view also, if you take Google. So it is getting doubled less than 18 months. And you need to think about what kind of tools or techniques that we can incorporate to handle such a massive volume of data. So that is one of the concern that is to be considered. And another one, if you consider variety, that speaks about what is the complexity existing in the data. As I said already, that it's not only in a structured format. We do have data in multiple data formats like structured, semi-structured, and structured. As I pointed out, almost 80 to 90% of data existing is unstructured. And what we have, or well-established platform, is to handle only structured. And many researchers, though they are handling structured data, and of course text form of unstructured content, but the prime interest or focus in near future will be towards video analytics and audio analytics. Simply to say streaming data. Many have not even attempted it. It's a prime focus or much interest in the area of research, video analytics and audio analytics. So different formats of data which is existing will have different formats, different types, different structures. For example, it may be a text content, or data getting populated will be in the form of numerical data, in the form of image, audio, video, time series, social media, or multi-dimensional array format of data comes into this. So in that case, the data can be considered in the form of static and dynamic, or streaming data, we say. So in that case, your tools or techniques that you do have should ensure that is it possible to handle such a type of complex format of data. So when it is not feasible, then you can think about big data as a provision to handle such things. So not that the data is being generated from a single application. Then that is another important point. Which means the source of data is not from only one application. There may be a possibility that data may be populated from different sources for a single application. So that's why we need to think about, of course, it's a big challenge where we need to think about a proper mechanism to handle that. When multiple sources of data getting populated for a single application, we can't ensure that all the data which are getting populated is of same data structure, which means same data formats. We need to incorporate different data structures to handle different data formats. For example, for a single application, let us take in the field of medical healthcare. In healthcare, one format of data getting populated into the database may be in the form of numerical data. Another may be in the form of text content. Let's say if patient undergoes a certain treatment and if doctor suggests to go for some scan, or let us say similar kind of thing, then it will be coming in the form of image. So likewise, different data formats are getting populated, and there should be a technique to handle this, where traditional data sources fails to handle such a multi data formats, but big data has a facility to handle this, and this challenge could be very well overcome with the help of big data technologies. So where we need to extract the valuable information from such a data formats, of course, this challenge could be very well overcome with the help of big data. Now, another V which I have mentioned earlier is velocity. As I said, data generated from different sources, it is being generated at a very faster rate, and your resource should be capable of getting such data from various sources, and also capability to handle on demand, which means on fly your data should be collected and it should be handled, and you have to extract some valuable insights from that for taking some decisions. When you do take a late decision, obviously we may miss certain opportunity. Let us get into some example like e-promotions which are being considered nowadays on the social media. So based on your current location or your purchase history, let us consider a scenario where you're traveling in some city, and when you're crossing a popular shop, that shop may track your information and try to populate some promotional what we say tickets. Through that we could able to get some discounts or purchase. If you are about to cross or very near to that shop, and if you do get populated messages from their sources, then you may think about purchasing some product from them. When you of course when you move away from them, and if you do get such a ticket, you may show interest or you may ignore it because you have crossed that particular location. So likewise, the location-based analysis or analytics is also going to play an important role in near future. So e-promotion or e-tickets which are being provided for customers are much important, and location-based extraction and doing such analysis and responding back is much important from a business point of view. And one more example, if we do consider in healthcare, you have adopted various sensors to monitor the activities of or to diagnose or to monitor the deviation of with respect to a particular patient. So you have placed different sensors and you are about to process any abnormalities existing with respect to a patient. So your doctor may be residing in remote place. Based on the input extracted from different sensors placed in the body of the patient, where doctor has to recommend some medicines. On that basis, the treatment should be carried out. If that is the case, if your system is not capable to analyze such data from sensors and not responding in time, of course, the late decision may even cause death. So in such cases, this big data technology can be very well adopted to handle even in such a sensitive situations also. Veracity, the another characteristics where I said the uncertainties which are existing in the data should be handled and removed. Like we say, noisy content present or some abnormalities existing in the data. Whether these things are to be taken into consideration or you have to remove this, which means when you remove such abnormalities existing in the data, whether it makes an impact or it does not makes an impact. So all these are to be analyzed clearly before you do handle this. So big data has a provision even to handle such a type of uncertainties existing in the data. Coming to next one and most important characteristics in big data is value. When you consider any business which always starts and ends with almost the business use cases. So value is one of the component being taken into consideration in big data nowadays, for which the companies may incorporate several analysis where they do apply or incorporate various statistical models and they do perform some analysis. On that basis, a company running a business can take some decision in time or that helps them to generate much profit or on a particular like for example in a year-end sale, whether Amazon has to maintain what is the amount of stock that they are supposed to maintain in the year end, what kind of product that they are supposed to consider for selling, and based on the previous year where they have to take some decision on that basis, they can maintain the stocks. And when the product are being delivered in time, of course, the customer may get satisfied on immediately. They may also look for placing such orders with the same kind of business companies. So these are going to impact, of course. So that's why value plays a very important role when it comes to handling such a huge volume of data. Right now, coming to sources from where this data is being populated, where it starts from a small ERP application to big data sources, which means data from a small ERP, like the purchase details or the payment details or the purchase history concerned to that, all this will be available. Let's say a small organization running this may maintain such data. And of course, it is in terms of megabytes. And the same thing which is being maintained for a span of 5-10 years, for this data becomes a huge data. So like CRM module where that maintains the details about the customer information or the contact details and other related information, which will be in terms of gigabytes. And of course, when you consider web data in terms of web logs or in terms of marketing trends or dynamic nature of information being maintained or pricing being done dynamically, all these source of information which are generated through various web sources. And of course, when you consider uh, big data sources, which is being populated from various sources, You can consider data being populated from various sensor devices or from social media, where it is being populated in the form of text, in the form of video, in the form of audio, or in the form of, let's say, multimodal data, where you may have an image and text is being placed on top of such image. So if you consider this, a huge amount of data is being populated, and which we call it as big data, like in terms of petabytes and petabytes and so on. So now handling such things are highly complex, where you do require different tools to manage this, and choosing a right tool is much important. Which tool that we are supposed to use? You may have huge or massive volume of data. What is your need and how you are going to handle such a massive volume of data? So in such cases, you need to think about an appropriate tool or appropriate algorithm to handle such things and get the insights from this data. Now, this is just to understand how a big data architectural framework is being used in real time. So if you see at the bottom, which is data sources, as I mentioned in the previous slide, for big data, the data sources are from different sources. It may be from medical source, or medical records will be part of it, or weblog data, data in the form of text, audio, video, or data coming from, let's say, drug industries. So likewise, we can take these sources of data, of course, which forms or which provides as an input to this big data architecture, or which will be taken to handle in the big data. And now when it comes in the form of different data formats, of course, you have to think about what kind of provisioning model that you are going to provide to store this data. So data comes from different sources. You have to see that whether you can store such data. What is the data formats that you have to provide? In which data formats it fits to store? So that you have to think about it. Like what kind of data storage that you are supposed to use. For example, we may use some distributed storage medium to store this data source, or it may be a database or NoSQL database or fast fabric database. So likewise, we need to think about, or even data warehouses also. So where you are going to store this data. So a provisioning model should be there, which gets data from different sources. So once if a storage process is completed, then you need to think about data injection, integration, and processing services. Like how you are going to handle this data, how you are going to integrate. In some cases, we may need to take data from different sources where it is stored or distributed across different storages. So what kind of integration tool that you are going to use? And when you think about, most commonly we go with like traditionally where in big data they start with Hadoop. Earlier they are sticking, or most of the application where they have used only Hadoop based tools to handle this. Now it is getting evolved. Many are moving towards Spark in replacing this Hadoop because it has its advantage. So likewise, what type of distributed or like we can say the tool that handles and provides high performance, and what kind of data processing environment you are going to use, all these are at the next level or next layer in this architecture. And further, how you are going to manage this and how you are going to provide this data based on the requirement. So where data has a service, which is a component which is going to provide based on the need. Like for example, if it is about a social media point of view, they have to understand the customer sentiments, and on that basis they have to populate different promotions by which the customer can select that option and can go for purchasing a product. In that case, it may give profit for such a company. Like for example, if some data is being populated when you open Facebook or when you open Amazon or any other, so that may of course benefit in terms of business for them. So all these are to be taken, like where these companies will be taking into consideration and they develop applications accordingly. Like they may go with some sentiment analysis or text analysis, or they may think about what kind of business intelligence models that they can apply, where they develop some predictive models on that basis, where they can extract valuable insights and take some business decisions. So all these are, of course, at the next layer, on top of which is user access. So where user will be given with some authentication to access this data, on that basis where they can able to extract some valuable insights which is generated from different sources. So this is a fundamental big data architecture framework which is adopted. Could this may deviate slightly with respect to some application, but this is a generic big data architecture framework which is widely being adopted. Now, coming to some applications where this big data is in practice. Now, let us look into some of the applications, how it is being used in reality. So, one, let us discuss in terms of how companies are using this technology to understand or to target the customers or understanding the mindset of the customers. So it is one of the most widely used or most widely used application area, we can say, to better understand the customer behaviors or preferences. Like you can see, most of the social medias are being used either knowingly or unknowingly. We try to provide our information to them, and that is what they are trying to use and convert it into big business. For example, let me try to give you some example. Swiggy, most of them might be using, and of course they are generating a business of more than 700 crores turnover in a year. For example, we may be looking to order maybe idli or dosa, which is being a kind of popular food in our region. You may be just browsing to go and purchase for, or maybe placing an order for idli or dosa. Then immediately they may try to look into your previous history. At one point of time, maybe earlier, you might have browsed to purchase some pizza. Now they try to tune your mindset to convert your purchase, to place an order for idli or dosa in terms of uh, ordering pizza, where it pops up with a message saying that when you purchase one, you may get one more free of cost. So in that case, your mindset will get converted towards uh, purchasing the another product, which means your initially your mindset will be purchasing or thinking in terms of purchasing one product, but ultimately you may end up in purchasing another product. So which means they are looking to extract your valuable information which are hidden already, and from that hidden sources they are trying to extract and convert it into a very big business. This is what happening. And of course Swiggy says that in another 5 to 10 years they are going to decide what is the product that their customers are supposed to eat rather than deciding by the customer himself. Like for example, if I am a customer where I'm placing orders in Swiggy, I'll not be given with a choice of ordering what item I'm supposed to order. Rather, they'll decide what is the item that I'm supposed to order. Right? In about 5 to 10 years, this is going to happen. That is what a Swiggy statement says. Right. Coming to this, another area is optimizing the business process. This is again being used by many companies. As I given one example, let us say Amazon online company, shopping company, let us consider. The company is about to decide how much stocks that they are supposed to maintain in a year and sell. Consider that it is a new year 2023. What kind of products that they are supposed to populate in the Amazon websites, on what basis they are supposed to attract the customers, what are the products which are popularly sold in the previous years, and what kind of product is much interest in the recent time. So all these statistics they are supposed to take. On that basis they are supposed to maintain the stocks, right? So where they have to generate, where they are supposed to develop a prediction model from different sources of data, and they have to decide how much stocks that they are supposed to maintain. So this big data could very well help them to maintain this supply chain with respect to these retail markets. And interestingly, it will also say what is the best route that the product can reach the customer. So this is also being done in terms of prediction. So this big data technology is being used for this to understand, and of course can develop a prediction model to take some decisions. The another area is healthcare. Healthcare is one of the major adoption of this big data, even from the initial or from the inception stage onwards. This industry has started using this big data platform. As computational power drastically increased, where you can think about the entire DNA sequence can be analyzed, and that could help the let's say doctors to understand the nature of the disease and could able to better treat the patients in advance. So like predicting the particular disease pattern could be very well analyzed. Earlier days where they take few days to perform this analysis, and now the resource which are available and the technology, big data technology could help them to understand or understand the disease pattern with their analysis within few minutes and could able to treat that patient. This is one example. And another is which is already being used in most of the developed countries to monitor the babies in the hospital. If a particular baby is prematured or let's say sick, to monitor and understand their behaviors where they are trying to use this, or to record and analyze the heartbeat and breathing patterns where they are trying to use this with respect to that unit. And more interestingly, algorithms are being developed and being adopted in a big data platform before a particular symptom appears with respect to a disease. Now it is possible that you can able to get such information prior, 24 hours prior, you can understand, or doctors could able to understand. So algorithms are being developed for such type of problems. Like some symptoms, a disease symptom may appear 24 hours later in a body of a patient. Now, algorithms are supporting, and where doctors could able to make use of that predictive model to analyze what kind of disease pattern may possibly appear after 24 hours with respect to a patient. And interestingly, this big data technology are widely being used, and algorithms are developed on that platform that helps the doctors to develop these predictive models and understand the disease pattern priorly, 24 hours priorly. They could able to understand how the nature of this disease is going to be. And another interesting area is sports. Everyone might have noticed a lot of changes during the sports events. Now, number of sensor technologies are being incorporated in order to understand what is, what kind of performance that consistently a particular player, of course, in a span of 2 months or 3 months, they'll be consistently watching their performance, and they try to develop a predictive models, and that could help to change the pattern of gameplay, where that helps a particular player to change, where it will try to point out the weakness areas of a particular player and how to change the game pattern. So this helps them to play much better in the upcoming games. So this is another area where this big data technology is being widely used. And now you could see that like technology is being used to represent the prediction models, like which team is possibly going to win. And based on different statistics, they'll try to say. Of course, it is a dynamic nature in terms of some games where the next moment there is a possibility that it may get changed. But in general, it is possible to predict certain things based on the nature of the game. So like most sports have adopted this big data analytics, and especially video analytics is very widely used to track the performance of each player in different games like cricket, football, baseball, and some games where they have widely incorporated this technology. And especially you can see that sensor technology is being used. Earlier, if you consider in terms of cricket, let us say, earlier where they have not incorporated much technology. Nowadays, very particularly they could able to or very particularly they could able to understand and could able to say the decisions. For example, if let's say if bowler or let us say batsman, let us consider whether it has hit on the bat or on pad or on the arm. Now it is possible to recognize where sensor technology are being placed. Even on the stems you can see sensor technology where they are adopting. The moment the ball hits, it will the stump is being incorporated with some LED lights where it glows. So likewise, various technologies were incorporated, and big data adoption is widely there, right? In order to change the game pattern or in order to improvise their game with respect to a particular player or with respect to the whole team where they are incorporating this. And big data is being used to improve the sports performance of a particular team or even a particular player. And another interesting area is Sun, a very popular research laboratory, uh, like where they have incorporated this technology in a physics lab, where a popular project, of course, most of them might be even aware about this Large Hadron Collider, the world's largest and most powerful particle accelerator project. So where they attempted with a huge amount of data in order to unlock the hidden secrets of our universe. In that project where they have used this technology in which nearly 65,000 processors they have adopted, where clusters of nodes are maintained and big data clusters have been carried out on this. 30 petabytes of data they have analyzed, and it was distributed across 150 data centers. The computing power of thousands of computers have been used here, and this has been distributed across more than 150 data centers. And this is one interesting project, where they have used this big data technology. And another interesting area is about security and law enforcement. Most of the developed countries, like particularly USA, has widely adopted this in this application area, right? So in order to improve the security and law enforcement, where it is widely used, big data is widely used. For example, National Security Agency in USA has used this particular technology in order to foil the terrorist plot areas where they use this, and to detect and prevent the cyber attacks which are taking place. They use this technology. and particularly the police department have used this big data tools, of course, in USA, where they have incorporated to catch the criminals or even to monitor or to predict the activity, of course, criminal activity being carried out. So where they are using this. And more interestingly, credit card companies have used to identify the type of transaction being carried out. Right? Is it valid transactions or not? Where they are using this technology, right? Even many banks, few have. I mean, like for example, top banks have adopted this technology to predict whether the credit cards could be issued to a particular customer or not. So that type of analysis is being carried out, for which they have used this big data technology. Now, particularly, we'll get into what type of tools that we can incorporate in big data scenarios. So this is typically the tools which are, of course, part of Hadoop ecosystem. But still, let me point out different tools which plays different roles in handling big data. Or in a big data environment, these tools plays a very vital role. I have not listed out the complete set of tools, but more important tools and their roles has been addressed here. Or collectively, we can also call it as ecosystem. In that, the more popular one is HDFS, Hadoop Distributed File System, which is part of Hadoop framework. Or the moment you install this, where you do get this HDFS defaultly getting installed. And that is the file system which provides a facility to store your big data. On top of which, where we do have yarn, which is yet another resource negotiator, like for processing and cluster management, where this tool is being used. Earlier to or in the earlier days of Hadoop, this provision was not there, but in the later versions of Hadoop, this has been incorporated. And apart from this, you can see other set of tools. As I said uh, earlier, or even we can say 3-4 years back, most of the big data companies were widely using this Hadoop. But now slowly they are migrating from Hadoop to Spark, or even we can say almost all the companies have started moving towards this Hadoop than, Spark than Hadoop, because you have a lot of advantage in case of Hadoop, where it is a horizontal scaling approach, but whereas in Spark, where we do adopt a vertical scaling, so in memory computing is being carried out. So where the performance with respect to handling huge data is much better. So that's why slowly they are moving towards this Spark. Or we can say almost all the companies have started using this than going for, or very minimum applications are running on Hadoop nowadays with MapReduce, Hadoop with MapReduce technique. And now coming to this other set of tools like Storm and Kafka. I have pointed out in my presentation that in near future, where we could see that most of the analysis will be, or the prime interest towards video analytics and audio analytics rather than text analytics. So where the tools like Kafka and Storm can help you to handle such a streaming data. And this provision is, of course, the tool has provided such a facility to handle this. And another one is like Drill and Hive. Hive almost looks like a query processing tool where big data query processing can be very well handled. Or simply to say SQL, or if I'm not good in Java, or if I'm not good in Scala, which is being executed on Spark. So if I'm not familiar with this technology, but I'm smart and good enough in a database, then I can think about adopting this Hive and handling like a query processing where I could able to adopt. So Drill and Hive are the tools available to handle this. And Mahout is, of course, a part of Apache Hadoop, and which is not being widely used nowadays, where people are moving towards Spark MLib, machine learning library supported in Spark. And Pig, almost it is not existing, but it is part of Hadoop ecosystem. In case if I'm not good in Java, or if I'm not good in Scala in writing MapReduce programs, where I can think of using this Pig scripts or Pig Latin scripts, which are like scripts, like scripting languages. It looks similar to that. So if I'm interested towards that, I can adopt this, but this is absolutely not in use in industries nowadays. And Sol and Lucency, where these tools are used for searching and indexing, and for that purpose, these are widely used. And in the ecosystem itself, you have Uzi. For job scheduling purpose, you can use this. And HBase is a default database part of Hadoop. For handling unstructured data, you can very well use this NoSQL database. And of course, if you see this Hadoop ecosystem where Ambari and Zookeeper are being used, because it runs on a cluster and you do require a facility to manage and coordinate this. For that purpose, these tools are being used. And in addition to that, you can see other set of tools like Scoop and Flume. Whenever if you are about to populate your data, let us say I have my data in a database, traditional database, but which is huge, and the performance was not good with respect to my traditional processing system, where I can think of bringing this uh, data available in my database to Hadoop and handle this, where Scoop is one that provides a facility. And Flume, when you are about to bring this unstructured or semi-structured data into your Hadoop platform, where this Flume is used. Of course, you can see this set of tools are available. Apart from this, even there are some more tools which are available to handle this huge and massive volume of data. For storage, as I pointed out already, Hadoop distributed file system is widely being used. And apart from that, cloud storages are also being used. S3 model is being used for storing the data in the cloud platform to handle or to process that data, where they do use this Elastic Cloud Computing or Google App Engine, Elastic Beanstalk. So these are widely used servers in the big data platform, especially when you work with cloud environment. And for processing, where you can use R. R is most widely used for data analysis, where it is possible that you can incorporate R with Hadoop, R Hadoop, or even few more tools supporting to handle this through R programming. And coming to Yahoo pipes, these are other set of tools like pipes, mechanical truck. Yahoo pipes are widely used to aggregate the web feed or web pages and other services, especially when you are about to build data mashup. For example, when you are going to integrate data from multiple web sources, where you can think of using this Yahoo pipes. Of course, for all applications running on Yahoo, where they are using this Yahoo pipes. And mechanical truck is another one, where Amazon is using this to outsource the business. Like it is a kind of service being provided on Amazon platform. Like if I want to provide, or if I want to outsource my business in terms of processes and jobs which are to be distributed across different workforces In such cases, this mechanical truck is being used, and it is from Amazon. And another one is Elasticsearch. So this is a search engine based tool where it makes use of Apache Lucene library. And modern search and analytical engines are adopting this elastical search, and this is completely an open source tool. And another tool for processing is Datamare. It is one of the, or we can say, modern analytical tool, which is especially built for warehousing. Or simply to say, it's like a tool that provides all-in-one solution. For example, when you are about to get into exploring the data, or you are supposed to prepare your data for analysis, or after preparing your data where you need to go with analysis, after analysis you need to perform visualization, and later if you want to promote like cataloging, all this can be done on a single tool, where this data mare is one that provides a facility to handle this all in one, or simply to say, an all in one solution is being provided through this data mare. And another tool, big data tool, is Big Sheet. This is from IBM. IBM has introduced this, or it is part of another tool like InfoSphere. So in that, where it is part of it, like this is widely being used in the big data platform, or to gain a big insights from the available data. This is widely being used, and this is going to work or similar line of Hadoop, where IBM has developed this. IBM specific technology is being incorporated here. And this tool more or less looks like a spreadsheet style of usage, especially used by business people, or whoever is working with big data, business users working with big data, especially they make use of this particular tool, Big Sheet. And another one is Tinkerpop from Apache. It is a kind of graphical computing framework to handle graph databases, or analytical system, graph analytical system, like mostly in a warehouse systems, where they adopt this wherever a graph database or a graph analytical systems are being incorporated, this Tinkerpop is being used. But these are some tools which is widely being used in the big data platform. You should not conclude that this is the only set of tool. Of course, you have still a lengthy list of tools which supports for wide variety of usage. But what I have listed is the most popular and widely used tools in the big data platform. Now, almost we have reached to end of my presentation, where let me conclude this with some interesting statistics and facts before I conclude this. Nearly 2.5 quintillion bytes worth of data is being generated every day. And interesting here is 70% of world data which is generated on a particular day is user generated data. Of course, machines also generate some data. The percentage is only 30, but 70% are user generated data. And over 44 zettabytes of data is existing in the entire universe at present. And 2.7 zettabytes of data exist in the digital format, and 235 terabytes of data, especially collected by US Library of Congress. And nearly 200 million has been invested in the recent years, especially for big data project from USA government. And global big data and analytical market worth is about 274 billion. This is an interesting fact. And that is the reason why they do say that there is a huge demand or a huge market is there for this particular technology. And when you think from Facebook point of view, it stores, access, and analyze more than 30 petabytes of data generated from the user end, right? Which means this is the total volume of data approximately estimated how Facebook is handling in a day. And 90% of Hadoop users are performing analytics, which was not existing earlier, or which was not possible earlier, but now most of them are using this to create a predictive models and develop the predictive models on top of Hadoop. And Walmart handles more than 1 million customer transactions every hour. And of course, it is nearly 2.5 petabytes of data are getting into their databases. And another point which I'd like to mention here, Walmart is another big company which is making use of this technology. For example, products which are placed in the Walmarts are not being carried out by the employees of Walmart nowadays, where it is being processed, or like, for example, a particular product has been noticed with an expiry date, and this is being recorded by humanoid robots, where it goes and scans about this detail in a particular area, and it brings those product and placing it in another end, which are not being handled, where big data technology is being widely used by this company. And this is one company where they started working on video analytics effectively. And more than 5 billion people are calling, texting, tweeting, and browsing on mobile phones worldwide. And this is the source for big data, of course. Akamai analyzes nearly 75 million events per day in order to target for better advertisements on the social media. They are, of course, handling nearly 75 million events in a particular day. Earlier, for decoding the human genome, the resources or the system facilities which are available took nearly 10 years to process this, but nowadays this is being handled less than a week. You see how technology has improved and how these tools are playing a huge role in handling such things. When you consider from Google point of view, where 20,000 terabytes of data they handled in 2008, but at present more than 20 petabytes of data they are handling. Google has not only provided the numbers, but how much data they store. But nearly 40,000 search queries are taking place every second. This is recorded. This is being analyzed. So 3.5 billion searches per day is taking place. And you think about how they are handling it. And of course, they do plays like Google Trends. And all these things are taking place after analyzing this data. And interestingly, in a year, 1.2 trillion searches are being done through Google. This is one interesting fact. And at present, there are 100,000 Google searches every second. So this is another thing taking place. And Netflix, if you see, they says nearly 1 billion per year. Of course, the recommendation algorithms that has been developed in support with big data technology, they are nearly saving $1 billion per year. And 72% of manufacturing executives says that they rely on this technology to improvise their productivity. And supply chain management is another interesting area where this technology is being used. And that industry says that it could surpass nearly 7.1 billion globally by 2027. This I have already pointed out that 80 to 90% of data which are existing is almost unstructured. The digital data which is existing, about 80 to 90% are completely unstructured. And this is where the prime focus should be. 80 to 90% could not fit into the traditional resources or structured databases or structured data processing tools. 80 to 90% of data which is in the form of unstructured, like it could be in a running text, it could be in an image format, video, audio. All these are prime interest in near future. And large databases like AT&T, where large volume of data in one unique database itself is around 312 terabytes. And the largest number of row in one database itself is about 1.9 trillion. So this is just to show how they are handling, how these companies are managing such a huge volume of data and how they are handling this complex formats. For that purpose only I have listed out the statistics. So that's all from my end. If there is any query, please you can ask. If possible, I could able to respond to that query. Hello. Hello.
Dear participants, you can ask any questions regarding this one, the afternoon evening session.
Sorry, sir, we are learning a lot of things, sir.
Any query, ma'am?
No, sir, just we are learning. That's no.
Okay. Anything else?
Dear participants, if you have any queries, kindly ask the questions. If you are not able to unmute yourself, you can put the message in chat window also. Sir, I hope we can wind up the session. So thank you
Yes.
very much for accepting the request for as a resource person for this wonderful 1 week FDP, sir.
Yes.
On behalf of management and the Department of Computer Science Engineering, I'm warmly thank you, sir. Thank you.
Yes.
Thank you very
Sir,
much.
if you give me an opportunity for 1 or 2 minutes, could I speak?
Yes, sir. Definitely, sir. Thank you.
Yes.
You
Yes.
can
Sir.
you can start.
Yeah.
Yes.
Yeah. So I thank all the participants for patiently being for this session for almost 1.5 hours. And also I thank management and coordinators for giving me this opportunity. And my special thanks to Dr. Jagadeesan sir for providing this opportunity. Thank you. Thank you, one and all.
Thank you, sir. Thank you. Dear participants, kindly fill the feedback link for today evening session. I will already share in the chat window. Very soon I will share in the WhatsApp group also. Thank you.
Thank you again, sir.
Thank you, sir. Thank you for your
For
opportunity.
me, net is a
Problem.
That's when I
Okay.
coming to.
Okay.
Thank you very much, sir, for your
Thank you, sir.
your wonderful sections.
Thank you.
Thank you, Muthu, sir. You carry on, sir.